Yeah, I don't give it to you because it's not a formula that they give in the summary section. Is there a desire for me to go over those other problems where they use the same formula?
I don't think so.
Not from Patrick. EJ?
No.
You don't look happy. I'd be glad to do it if that'll make you happy. Other questions on 30?
Oh, yes. Alright, I'm sorry. For number 37, when they use the resistance formula.
All right, hold on. Let me get, all right, number 37. The acid shown.
Actually, no, that's for chapter 31, I'm sorry.
Oh, okay.
Um,
Unstuck in time.
I have another question about question 15.
Question 58.
No, 15.
Question 15. All right, for the proton, in problem 14, what are the magnitude and direction of the magnetic field? Is that the one?
Yeah.
Okay. Is there a specific one or just in general? A specific question or?
For the angle,
Yes.
I assume they did inverse tan of 4/3.
So common type of cosmic ray for the proton at point A. Well, it depends on which angle they're looking at there. I assume, I'm looking at it wrong. So it's going down. And so you would want the angle between R and V. So yeah, arctan of 4/3.
Yeah.
Yeah. I just want to point out a difference between the two approaches, what the book does, or what the person who wrote the solution does and what I do. I stick with the cross product here, and they are thinking through the direction and recognizing that if I have A cross B, the magnitude of that is going to be AB sine of the angle between them. And so they're finding the angle, and I'm bypassing that step by just sticking straight to, I have it in rectangular form. So I'm just using the cross product of rectangular form. It gets you to the same place. All right, was that your question? Or is that just part of it?
Yeah, how come it's not like 3/4?
Because unlike the problems that I do, because I tend to do problems where particles are moving horizontally, they decided to have the particle move vertically. So their particle is moving that way, and they're looking at this point in question. So when it's here, that's my R vector, that's my velocity vector. So if V cross R, I'm looking at this angle. And that's 4 and that's 3, so that's why they do arctan of 4/3. Because they don't want, arctan of 3/4 would get you that angle. That is not the angle between the two vectors of which I'm cross producting. Cross multiplying, that's the word. I feel like you're not satisfied with that answer.
it's 4/3,
instead of 3/4.
yeah.
All right, I'm gonna rotate the problem. So they have the particle going down, and this point A is off to the left. Which I guess from your point of view, that way. So the way I have it drawn there, so if I rotate the problem, and probably should not use those. All right, so if I rotate the problem so that the particle is moving this way, V, and the point in question is here, so I've rotated it counterclockwise 90 degrees, and that's point A. So when the particle is here, that's where my positive particle is. I need that angle right there. Or it's the question of why would you want that angle?
No.
Okay, you're good with that angle. Well, from the drawing, the distance from the path that the particle is taking, the closest distance to where A is, so that distance, according to the problem, is 4 meters. And the distance from where the positive charge particle is to that line is 3 meters. This is the same problem as that, except I've rotated it. And so this angle right here, I know that the tangent of theta is the opposite over the adjacent. So theta is going to be the arctan. 4/3.
Why don't they do like arcsine, or cosine?
Oh,
Yeah,
do the arc sine of 4/5 or the arc cosine of 3/5?
or no, the inverse cosine of 3/5.
Yeah, they could have. They would have gotten the same answer. Unless, of course, the usual caveat of the math people have been lying to us. One plus one equals 2. Yeah, right.
Okay, that makes sense.
Okay. Other questions from chapter 30? All right, so let me pause this and then make a comment about the quiz. Chapter 31. You had a question on problem 37? As in, where's the answer?
Yeah.
All right. Yeah, I got thrown by that too, but it turns out when I create this, I'm doing a cut and paste, and sometimes it does funky stuff, and I hopefully I catch most of them, but this time I didn't. The rest of the solution for 37 happens right above that. So you got a little bit, so 30 says 37 here with the solution that seems to stop in the middle of the problem. Then you come up to here, that's the rest of problem A, and then problem B right there.
My question was,
Sorry.
for the length in the resistance formula.
Yes.
Why didn't they just use 33 or 0.33?
For the, all right.
Yeah.
It's a common issue with interpreting the problems there. So there's 2 different lengths involved. So if I have a solenoid, I got a coil of wires here. There's the length of the solenoid, which is this length right here. And then if I took that wire and I stretched the wire out, there's the length of the wire. And then first length of the solenoid.
Oh.
That's the thing. And then there's a third length that sometimes pops in the fact that there's a master set question I know I do for 152, where I say I measure the length of, it's a subset of the wires. or I find the length of 30 coils is 10 millimeters or something like that. So sometimes a third length pops into it. But length of the solenoid is end to end of the actual mechanism itself, as opposed to length of wire.
Okay. And when you're using the resistance formula, by length, they mean the length of the wire?
Yes.
Okay. That makes sense.
Other questions from chapter 31?
No. 31 and 32, I was a little confused at, like, which way they were integrating and, like, what direction and.
All right, so figure P1.31, all right, so I got the figure there. It's just cylindrical conducting shell carrying a current to the right. Non-uniform current density. Then give you that formula in the region R1 to R2. C is constant with the magnitude of the magnetic field at a distance RA within the conductor. All right, and your question was?
Well, I just didn't understand how they approached the problem. It was like suddenly there's this formula, or they put all these things together. I didn't quite understand how it worked.
So, when they stuck the J in there, is that the point?
Well, that and just like, are they integrating from the center outwards or along the wire or?
All right, so when you have, so if we look head on into the wire, and I believe this was R1 and R2. They use capital letters, so big R1 and big R2. There's nothing in the middle here. It's just the big cylindrical tube. And they're asking about a point here, which they label as RA, and I guess there, which is RB. When you do an Amperian loop, you're just, well, it's a line that connects up with itself. And I know for the purists in the group, it's not officially, it's not a line. But, so I'm creating an Amperian loop of radius RA there. I know from Ampere's law that B dot dl, so the magnetic field along whatever line I'm doing, is going to be equal to mu naught times the current enclosed inside that. And I know that current per area is, using crude approximation here, current over area is equal to the current density. So you're looking at a cross section, it's how the moving charges are distributed over that cross sectional area. Or the calculus version of it is I is equal to J dot dA. And so they took that, substituted it into there.
And that area is the cross-sectional area this way, like a.
You're doing integral here. I know that dA, I know the area of that, it basically would be this area right here. Since I don't think J, well, there's nothing in the middle, so J has to be defined from R1 to R2. So that would be the area. Is that sufficient, or did I miss the ultimate question there?
No, I think so. I just didn't quite understand how things fit together,
Okay,
but that makes a lot more sense now.
okay, good. Other questions? Is someone about to come up with another question?
Yeah, the solution sheet didn't show the answer for question 59.
For 39?
59. 59.
59. see 59 right here. Is it that it got cut off short, or no? We're looking at different things?
Oh, no, oh my god, no. It's not different, it's,
I probably should somehow differentiate, like put a line between the problems or something. So it sounded like you resolved your question.
no,
Nope, okay.
there was a question that the solution sheet didn't answer.
Not sure which one it was.
Yeah, I'm looking through it right now.
So that's 7, 11, 17, 18, 19, 20, 22, 37, I've seen 59, 65. 69, 74, all right. There's at least something there for everything.
I'm guessing it could have been 37,
Because it was out of order.
because that was my reaction. I thought I was very confused. Why they just
Yeah.
left it at 1.57 ohms.
I can understand being very confused there, but I was very confused.
Never mind.
Okay. All right, shall we just do it then? Probably don't want to take that a second time. There we go. Again, you have 2 questions here, pick one. I don't know why I'm putting it downward, but start when ready.